In this video, we're going to continue to talk about connecting f prime and f double prime with the graph of f. It says that the graph of the derivative of function f, derivative function f means f prime, on the interval -4 to 4 is shown in the figure 5.2.6, which is this right here. And we need to answer the following questions about f. Notice it says about f. Justifying, which means we have to explain how we got the answer. Each answer with information obtained from the graph of f prime. So part A says, on what interval is f increasing? What's given is the graph of f prime. Again, this is a graph of f prime. So if you come up with the f prime chart, because f prime chart gives you information when f is increasing and decreasing. Look at the graph of f prime. What are the critical numbers? Critical number is when f prime is equal to 0. It's right here, -2, 1, and also at 4. We're looking at -4 to 4. So we have, from -4 to 4, between -4 and 4, we have two critical numbers, which is at -2 and 1. Now, this is a graph of f prime. F prime is positive because graph of f prime is above the x-axis. F prime is positive from -4 to -2. And it's also positive from -2 to 1 because f prime, the graph of f prime is above the x-axis. From 1 to 4, the graph of f prime is below the x-axis, which means f prime is negative. So therefore, we could conclude that f is increasing from -4 to -2 and -2 to 1 because f prime is positive on those intervals. Remember, when f prime is positive, that implies that f is increasing. When f prime is negative, that means that f is decreasing. Now let's look at part B. It says, on what intervals is the graph of f concave up? Now, in order to find out concavity of f, we need a sign chart of f double prime. Because when f double prime is positive, that means f is concave up. When double prime is negative, that means f is concave down. But only problem is we only have the graph of f prime. Now remember, the derivative of f prime is f double prime. In other words, the slope of f prime. The slope of f prime is f double prime. So that means when f prime is decreasing, that means f double prime will be negative. And when f prime is increasing, f double prime will be positive. So first, when is f prime or f double prime is equal to 0? The slope of f prime. When is slope of f prime equal to 0? That happens at -2, 0, and 3. So that's when, from -4 to 4, f double prime is 0 at -2, 0, and 3. Because the slope of f prime is 0 at -2, 0, and 3. Now, what's happening from -4 to -2? F prime is decreasing. That means the slope of f prime will be negative, and slope of f prime is f double prime. From negative 2 to 0, f prime is increasing. That means f double prime is positive. From 0 to 3, f prime is decreasing. Therefore, f double prime is negative. And 3 to 4, f prime is increasing. Therefore, f double prime is positive. Now we have the f double prime chart. Based on that, we know where f is concave up. F is concave up on intervals from negative 2 to 0 and 3 to 4. Since you have to justify your answer, f double prime is positive on those intervals. Or you could say, since f prime is increasing on those intervals. Because when f prime is increasing, that implies that f double prime is positive. Part C says, at which x coordinate does f have local extrema? Well, we got this f prime chart from part A. And based on this chart, f prime chart, we know that we're going to have a local maximum at x equals 1. Why? Because the sign of f prime changes from positive to negative. At x equals 1. That would be your justification. Now, what happens at x equals negative 2? Nothing, because sign did not change. Now, what about the endpoint at negative 4 and 4? At negative 4, you know that the function f is increasing, so that is going to be the local minimum. So there's going to be a local min at negative 4. What about 4? The function is decreasing until 4. So you have two local minimum at x. So it happens at x equals negative 4 and x equals 4. Now part D says, what are the x coordinates of all inflection points of the graph of f? Now, in order to find the inflection point, we need the f double prime chart, which we got from part B. And you know the inflection points occur when the sign of f double prime changes, either from negative to positive or positive to negative, and the f double prime has to equal to 0 or undefined. And we know that f double prime is 0 at negative 2, 0, and 3 from part B. And look, sign changes. So we have inflection point, points at x equals negative 2, x equals 0, and x equals 3. And what will be your justification? Because the sign of double prime changes either from negative to positive or positive to negative. Make sure you write that down. I don't have enough space, so I'm going to leave that up to you. Now, finally, part E says, sketch a possible graph of f on the interval from negative 4 and 4. So in order to graph the f, we need the f prime chart and f double prime chart, which we got from part A and part B. These two will help us to sketch the possible graph of f. Now, notice, look at each interval here. Let's look at it from negative 4 to negative 2. What's happening? F is increasing and concave down. And we don't know exactly which y value we need to start from, so I'm just gonna say we're gonna start from here. So from negative 4 to negative 2, F is increasing and concave down. So it might look something like this. Increasing and concave down. Now what's the next interval that we need to look at? It's from -2 to 0. What's happening? F is increasing and concave up, because they're both positive. Increasing, concave up. So something like, again, we don't know how far we have to go up to. Increasing and concave up. Okay? Now, what is the next interval that we need to focus? 0 to 1. F is increasing and now concave down from 0 to 1. Increasing and concave down. The next interval is 1 to 3. Decreasing and concave down. 1 to 3. Decreasing and concave down. Again, we don't know how far we have to go down. Now finally, 3 to 4, what's happening? 3 to 4, F is decreasing and concave up. Decreasing and concave up. So this is a possible graph of F. Of course, depending on the y values, your graph might look a little bit more above or below, but it's okay because it says possible graph of F. Now let's look at this problem here. You got f prime of x equals 4x cubed minus 12x squared. Part A says identify where the extrema of f occur. So we need to look at the f prime chart, and we have the equation of f prime of x. So f prime of x is equal to, we're going to take the greatest common factor, which is 4x squared, and you get x minus 3. And you set that equal to 0 to find the critical points. You get x equals 0 or x equals 3. So let's draw the f prime chart. 0 and 3. Now we got to find out the sign of f prime. Let's plug it in here. Let's plug in negative number. This will always be positive, so you end up getting negative. Let's plug in 1. You get negative also, and then plug in a positive number. You get a positive. So we only have local min at x equals 3, since f prime, actually the sign of f prime changes from negative to positive at x equals 3. That'll be your justification. Now what happens at x equals 0? Nothing, because the sign of f prime did not change. Now part B says find intervals on which f is increasing and decreasing. So in order to do that, we need to again look at the f prime chart which we got from part A. And we know that when f prime is negative, that means f is decreasing. When f prime is positive, that means f is increasing. Therefore, f is increasing on the interval from 3 to infinity. Now, what will be a justification? Because f prime is positive on those intervals. You have to write it down for justification. Now, when is f decreasing? F is decreasing on negative infinity to 0 and 0 to 3. And what will be your justification? Because f prime is negative on those intervals. And part C says find where the graph of f is concave up and concave down. In order to do that, we need to find the f double prime. So f double prime is 12x squared minus 24x. And let's take out the greatest common factor, which is 12x. You get x minus 2. Now, what are the possible inflection points? That happens when 0 equals 12x or 0 equals x minus 2. So that implies x equals 0 or x equals 2. So now we could come up with the f double prime chart. You have 0 and 2. Pick a negative number and plug it into the second derivative. You end up getting positive. Choose 1, you plug it in, you get negative. And choose any number greater than 2, plug it in, you get positive. So when is f concave up? It's concave up. Now, I'm just using CU, but make sure you guys write it out. F is concave up on the interval from negative infinity to 0 and 2 to infinity. Now, what will be your justification? Because f double prime, the sign of f double prime is positive on those intervals. Now, when is f concave down? It's from 0 to 2, because on those intervals, f double prime, the sign of f double prime is negative. And part D says sketch a possible graph of f. So in order to do that, we need to go back to f prime chart and f double prime chart, which we got earlier. So let's look at it from negative infinity to 0. What's happening? F is decreasing and concave up. So from negative infinity to 0, f is concave, decreasing and concave up. So something like this. Again, we don't know which y value is going to hit because they didn't give us enough information. What's happening from 0 to 2? Decreasing and concave down. So decreasing and concave down. Okay, again, we don't know whether it's going to hit the y value of 0. We don't know that. It's just a sketch. Now, what's going from 2 to 3? Decreasing and concave up. And then finally, from 3 to infinity, increasing and concave up. So this is a possible graph of f using f prime and f double prime chart.